All right. I want to know how many of you have your driver's license. Raise your hand if you have your driver's license already. All right, too small of a group. Nice work, though. I'm going to go with something where I got like, I don't know, 7, 8 people that have it. How many of you have a permit? Raise your hand if you have your permit. All right, that brings it up quite a bit. All right, and by the way, if you have your license, you had a permit, so you can say you have a permit too. Okay, good. We'll go with people that have a permit. And then option B, just to keep it simpler, you have dark colored shoes. Raise your hand if you have dark colored shoes. Okay, good. This will be a good overlap one. All right. So the circle on the left is going to be you have your driver's permit or license, which means you had a permit before. And the circle B is going to be dark shoes. And I know dark's a judgment call. You get to make the call. All right. So who in here has a permit? Raise your hand if you have a permit. I got to count it this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, what's wrong with what I just did? That is a classic mistake that happens all the time. People are like, what's wrong with that? You put the 12 in the permit thing. See, that's why it's a mistake, because a lot of people like, can't even explain why it's a mistake. Yes? Yes, some of those people need to be in this number here. And if I say there's 12 over there, and then I add any other number in the little in-between section, in this little section, then the total will be more than 12, but there's only 12. So I shouldn't ask it that way. I know the total's 12. That means these two together make 12. So where should I put the 12? After the permit. And that 12 then will be divided into 2 parts. All right, the easiest way to do this would be to ask for the most difficult one, which is there shouldn't be too many people in this group. You have your permit and you have dark shoes. Keep your hand up if you have a permit and you have dark shoes. 1, 2, 3, 4, 5, 6. All right. Now that I know that, I know both of them, right? Because if that's 6, what's the other one got to be? 6. But people get this like all twisted. They'll say it's 12 people with permits, so they put a 12 here, and then they keep the 6 there. That's not right, because then there'd be 18 people with permits if I leave it that way. Okay, so don't just slap it in there. Next thing, dark shoes. Who has dark shoes? But I don't want to say dark shoes total, because it'll be a lot faster, less people to count, if I just say dark shoes but no permit. Raise your hand if you have dark shoes, but you do not have a permit. 1, 2, 3, 4, 5, 6, 7. Okay, that goes here. And who hasn't raised their hand up until now because you don't have a permit and you don't have dark shoes? 1, 2, 3. Okay. Now, I know there's always some kid that got confused in there somewhere, and like I know this probably doesn't add up to the total people in the room. If everybody answered perfectly, then it would add up to the total number of people in the room. Okay, so my next question for you is, if I say P of P, it doesn't mean PP. What do you think it means? The probability of getting, and this one always cracked me up because in Wisconsin, they have double letter highways. And of course, I went nuts when they finally came to the highway PP. Yes, there's a PP highway, and it's in Wisconsin. Okay, anyway, probability of a permit. That means if I grab a random kid like you, I've selected you randomly, even though you're in the front, which means it probably wasn't random. Do you have a permit? No. What was the probability that was going to happen? Well, I got to go with, he would have said yes if he'd have been in either one of those two groups. Okay, so what's the probability that was going to happen? He must be in this group or this group, right? And so then it was 7 plus 3 out of, and again, the total here, again, counting for the fact that somebody probably screwed up and they're raising the hand, or maybe I counted wrong. We have a total of 12 plus 10 is 22. Do you get how the probability of that was 10 out of 22? Why? Because Either he had this or he had that. And what does or mean? Add. If you haven't connected that in your head yet, you got to remember that or means add, right? Yes? That's a probability of not having a permit. Oh, I changed the question in the middle of it because he answered no, and then I said, so what was the probability that that would happen? And you're right. What I wrote on the board is probability of a permit. All we have to do to change it is one little thing, and you're going to learn a lot of little things today. A little dash like that could be construed as prime, but we don't say prime. It's officially called complement of, but the fast way to say it is not. Probability of P not means the probability that it's the opposite of the probability of P. So for example, let's say for the rain tomorrow. Let's say there's a 40% chance of rain tomorrow. Actually, it's higher than that. Let's say it's an 80% chance of rain tomorrow. You guys hear about that? Anyway, it's very likely to rain tomorrow. So let's say we have an 80% chance of rain tomorrow. To get to the probability of rain not, it's 20. If it's 80% chance of rain, 20% chance of rain not. Okay, so when you put a little dash on it, it means not. So this was actually the probability that you would not have somebody with their permit. All right, let's do a couple more easy ones first. I think there's too many people that are confused. This isn't that bad. What's the probability of D? Probability of somebody with dark shoes being chosen. I randomly select what's the probability to get somebody with dark shoes. What do you think the mistake answer is? 7 out of what? 22 people total. 7 out of 22 is a good try, but no. Why? Because these people have dark shoes too. Do you get that the answer should have been 13? Raise your hand if you had 13. Okay, awesome. Because either these or those both have dark shoes. All right. Next kind. Probability of permit or dark shoes. Let's say that I said, I'm going to pick a kid. And if that kid has dark shoes or a driver's permit, I'm going to give him $1. Well, or means add. My question is, what is the probability that I'm going to have to pay out that $1? I'm going to say it one more time. Probability of P or D. And I know what usually causes trouble. People are not sure if that middle number is included or not. So here's how I can prove it to you, because I know I'm going to have like 50-50. Some people are going to say that you include the 6. Some people are going to say you don't include the 6. Obviously this or means add that, but do I also include the 6 or not? Here's how you can tell. Ask these people, do you have a permit or dark shoes? And what would these people say? Yeah, I have a permit. Or, yeah, they would say I have a permit. Ask these people, do you have a permit or dark shoes? And these people would say, yeah. If you ask these people, do you have a permit or dark shoes? They're going to say yes. Unless they're going to be a real jerk and say, no, I have a permit and dark shoes. You know what I mean? They do have permit and they do have dark shoes. And I said, or, you don't have to have both. Okay, so bottom line, or is a big answer. Or means add. You add up all 3 of them. You should have added up all 3. And I get, smart kids even, get this one wrong. 19 out of 22. Or is a big answer. Conversely, and is a small answer. Do you get if I say, you're going to win if you have a permit and you have dark shoes? Now it's harder to win, isn't it? You know what I mean? Permit and dark shoes is only this one. So this one's and. All 3 of those are or. Okay, and then one more kind, not. So if I grab a random kid, you, what's the probability that she will have no permit? Don't say it, write it. Probability of no permit. P of P not. Well, permit's 12. That's not what we want. We want not permit. That's the other part. That's called its complement. 7 to 3 makes 10. 10 out of how many? 22. All right. The last thing we have to do with these is deal with the concept of givens. If I said, given I'm only going to pick from kids with permits, then what's the probability that they're going to have dark shoes? A totally different question than just the probability of dark shoes. If I say I'm only going to pick from people who have a permit, do you get these are out? And therefore what's possible is 12, not 22. See what I mean? Okay, and then it's 6 out of 12. So the probability given that they have a permit, here's how you write this. Probability of dark shoes slash, that means given. You probably have never seen that symbol before. Given that they had a permit. Probability of D slash P means probability that they have dark shoes given that they have a permit. And there's a whole bunch of little connections you have to make. Or, it's a big answer. You add things together. And, those are small answers because you have to have this and this and this, and that's hard to do. And so there's not many answers. Ands are small answers, ors are big answers. And I've tried to connect up. You generally do a lot of multiplying with probabilities. If you have choices, you multiply choices. These are all really good sayings. They're good enough, in fact, that I'm going to make a running list of them off to the side here on my real board. So those listening at home, you just have to write these down yourself. Or means add. And the one I am about to just talk about right here is that given changes what is possible. If I said given, I'm only going to pick from the girls. Do you get, there used to be 25 kids possible, and now it's down to like, I don't know, there's like 16 girls in here or whatever. Given changes what's possible. Where's the possible? Probability definition. Probability is what you want, wanted outcomes, over the possible outcomes. So givens change what's possible. That's the denominator. Okay, so one more time. This time it's going to be piano, SUV. I know you personally probably don't own an SUV, but do your parents? Okay, so what are the kids that are over here? They don't have a piano and they don't have an SUV. Okay, so who in here has a piano or a keyboard in your house? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Biggest mistake ever to put the 13 right there. People do it all the time. Where should it go? Up by the piano. And then I know the total of those two parts, this part and this part, has to add up to 13. So the next I'll ask is, who has a piano and you have an SUV at your house? A 1 and a 2 and a 3 and a 4 and a 5 and a 6. Okay. And if there's a total of 13, by logic, I know that this must be what? 7. And who has an SUV but not a piano? You have an SUV at your house, but not a piano. 1, 2, 3, 4, 5, 6. And who are the people that do not have an SUV and do not have a piano or keyboard at your house? A 1 and a 2 and a 3 and a 4. Okay. And this time I got a little better participation. I got 23 people this time. That's what they add up to. So now just try to answer this question. Probability of piano not. The easier question would have been just piano, and that would have been 13 out of 23. But piano not, that makes you jump over to these guys, and so it would be 10 out of 23. Raise your hand if you had 10 out of 23. Okay, awesome. Next, probability of piano or SUV. Let's see if you forgot my advice on how to do ORs. Piano or SUV. Did you get 19 out of 23? All right. And remember, ORs include the middle spot. What if I said piano and SUV? What would the answer be then? 6 out of 23. All right. And how about piano given SUV? If I only ask people who have SUVs, that's what that means. Given changes the denominator. It's not out of 23 anymore, hint, hint. Given SUV means this was the only thing that could happen. This couldn't happen. This couldn't happen. So if you didn't do it out of 12, you goofed. Now piano, of the ones that were possible, that's the only one that you can use. A really common mistake is to think it's 13, but I think you'd have realized 13 out of 12, you can't have that. That's more than one. Only people that were possible to pick from were these guys, not those guys. So 6 out of 12. Raise your hand if you had 6 out of 12. Awesome. And then a simple chart from yesterday. I always like to do a review problem of the day before. Heads, tails. Let's say we have a coin flip and it's 60-40 on heads. For some reason, this one side keeps them coming up heads more often. Maybe it's a weighted coin or something. Then, have you guys ever seen the trick where you flip a bottle over and you try to make it land? You flip it and you try to make it land standing straight up. Is anybody actually kind of good at that? Nobody is good at it? All right. So, we're going to say if it's a bottle flip, here, can you toss me your bottle for a second? Works a lot better if they have like something in them. But I'll just at least demonstrate. So you're going to try to flip it, make it land. Whoa! I'm trying to catch it and toss it at the same time. I'm going to just not even try to catch it. I'll just show you. I'm going to try to make it land just right on its end so it goes like that. Do you get how really hard that is? Because it's just going to want to bounce. Do you get that if I tried it 100 times, it might stay up once? But if it's like half full, it sticks a lot better. All right, can you do it? Yeah. Okay. That was terrible. All right. Toss me yours. I promise I'll give it back. It's smart water, so maybe it'll be smarter. Ready? Sure, the lid's on top. Tight it is. Oh. Oh, I need more rotation. Oh, yes! Thank you. Thank you very much. Okay. I'll be here all week. Nice catch. Okay, so this is going to be, it lands up or it lands down. It's probably only 10% of the time it's going to land up. 90% of the time it's going to land down. Very hard to stick a landing like that. So here's the thing. Do you get, if I put 10% up, you would have been able to figure out that that was 90% down? Because together, this and this have to make 100%. All right. Next logical leap, do you get if I didn't tell you this? You could have figured that out. If it's 60% heads, it must be 40% tails. And then there's one more way they do this. What if they didn't tell me either one of these, but they said the answer to this was 0.54? Do you get how you could have logically figured out that there's a 90% chance that the bottle would fall down? Because 6 times the 0.9 would have given you the 54. You could have divided that and figured out that that was 0.9, and then you could have said, well, logically, then this must be 0.10. If I add a 0 to this, it'll make more sense. Okay, all right. Then a typical question related to this. I'm not filling out the whole chart, just to save time. But you use the numbers that you need to. What's the probability of heads up or tails down? Do you know what or means? Do you know how to figure out the probability in the first place? Thanks for letting me borrow your bottle. Do you? Awesome. I'm going to fill it with water and use it next hour. This is going to be harder, though, because it's skinnier, and I think it's going to be harder to make it land. Say again? Well, I mean, yeah, also makes it harder. Sound like a guy with experience. All right. Heads up. That's this one. And together, you multiply that, and it's not 0.6. A lot of people confuse that. If you times it by 1, it'd be 0.6. It's 0.06. Raise your hand if you knew it was 0.06. Okay, good. Plus, or means add, heads up or tails down. And tails down would have been this one with a down, but there's a 90% chance of the down. So it's 9, and the 4 makes the 0.36. So we have two answers, 0.06 and 0.36. And if it's or you add, do you get that's a total of 0.42 or 42% chance that it'll either I'll get a tails on my coin flip, and then bottle will be standing up, or much more likely, I'll get a tails and the bottle will end up down. All right. I think that covers everything that you need to know. Oh, wait. One more on this. Remember the given? What does given change? Denominator. The given changes the denominator. What if I say given? I know it's going to be heads. Like, I've gone into the future. I've used my time stone. And I've gone into the future. And I have figured out that it's going to be a heads. What's the probability of up? All right, these are difficult, but I'm going to figure out all the probabilities here. This last one was 0.4 and the 0.9, which makes 0.36. And this is 0.04. And those are my 4 things that could happen, but wait, they couldn't all happen. Remember me saying that I went into the future and I know it was going to be heads? Do you get that only these 2 are possible then? So that's what it's out of. These aren't possible. So what's possible goes on the bottom. These 2 are possible. Put them together, you got 0.60 on the bottom. And what I wanted was what's the probability of heads up given that it came out heads for sure. If it came out heads for sure, that's the only things that are possible. Heads up is now 0.06 out of 60%. And if you divide it, it's 10%. And if you were like, wait a minute, answer's just 10%. Yeah, it is. You could have seen that right here. Because we already went down this road, and so we didn't have a choice anymore. Now it's only these 2, and we already know the probability of up. It's 10%. But the way you do it is you take what you want, which was this answer, over what's possible, which were these 2 answers. Do you get how it's always what you want over what's possible? It'll always boil down to that. And why did the what's possible change? Because I said given it had to be heads. And as soon as I say given, that changes the denominator. Now, the reason I'm really pounding on the rules is that we're only on day 3 of probability, okay? And it's going to get much more intense by the end. But these rules I'm giving you, they're going to stay the same. So when you see it's like, oh, it's this or this. Oh, that means that. Or is a given. Oh, that changes what's possible. Got to divide by something different. All right, and then there's one last thing I want to do, and that's the not thing. Let's say that the kid could make 1 free throw, he could make 2 free throws, 3 free throws, 4 free throws. What's the one thing I didn't mention? Yeah, he might miss everything. Give him 5 shots, he might make 0. Okay, now if that's all the things that could happen, what if I say the probability of this is only 10% chance? 24%, 31, 14, and let's maybe add them all up because 30, 45, 69, 79, 21. There we go. All right. So those are all my probabilities. What if I said that what's the probability he makes at least 1? Think about that. Doesn't that mean the same as not 0? At least 1 means this, or this, or this, or this. Do you get I could either add, or I could have taken not that. How do I do not 10%? What's the answer? 90. See what I'm saying? It's a lot faster than adding up all those other ones. So if you want the probability of not something, you take 1 minus the probability it will happen. So that's like the rain tomorrow thing. One more time on the rain tomorrow. Let's say it's an 85% chance of rain. So what's the chance of not rain? And you did it really fast in your head because you did 1 minus 85. That's what you really did. Or you thought, what could I add to 85 to make 100? Either way, it works. But all right. So I'd go 1 minus 0.1, and it would be 90% chance that he won't get 0, and therefore he will get at least 1. Okay, there. I did the little pre-teaching thing. Honestly. There's a couple more formulas and stuff I can show you, but I think I've taught you everything. If you actually remembered everything I've just told you, you got enough that you now know all of probability. Okay, no, not all of probability, but you know a lot. And we're going to divide this test into multiple tests. So the first test, you got a lot of it already. And we'll see how much sticks when you're looking at your homework. I'm going to pause for a second. We'll pull up the homework. All right, so here are the problems. I want you to do problems 1 through 5 today, which means you get to skip one big, long, nasty one at the end. If you want to, you can always go back and do those. It's not a bad idea. If you especially bomb something and you're like, oh, I've been doing bad on this, I better go do that last one. I think that's very mature. I checked last hour and 4 kids had gone above and beyond on last night's homework and done more problems than they had to. It's not like you're a better person. It's just if you're not getting as good as scores in here as you want, that'd be a way to try to help yourself. Okay, let's look at this first one. Do you think this really means that we have 0.1 of a person as a sophomore? No, that probably means 10% of the people are sophomores. I'll give you a clue. Later it's going to tell you that there were 500 kids that were asked. Do you get that that would have meant 50 sophomores out of 500? Do you get what I'm saying? So later they're going to ask you down here, let's say there was 500 kids, and you would have put, this would have been a 50 instead of a 0.1 or 10%. This is called a probability diagram. When they give you just decimals, obviously they're not parts of people, they are percentages. And so if it's 10% sophomores, then that'd be 50. You just take this times the 0.1 and you get that. Okay, now let's answer the first couple questions. Number 1, .10 represents, all you got to do is say what that is. And if you say sophomores, you missed a lot of things. That is not all the sophomores. .1 is just sophomores who are not in advanced algebra. I'm going to call it AA for advanced algebra. Sounds like an Alcoholics Anonymous. But anyway, AA is a lot faster to write than advanced algebra. Okay, .15 represents softs in AA. They're both. They're a sophomore and they're in advanced algebra. .12 represents AA not, what do you think I'm going to say? They're advanced algebra, but they're not what? Soft. And .63. What is that? Oh, that's the ones that are out there. They're not and not. Not what? Not soft and not AA. Okay, as I move down, remember, and is a small answer. If I said you had to have big feet and blonde hair, well, then that'd be a very small number of people, okay? And are small answers, or are big answers. Not, you've already learned the not symbol. The one thing I have not taught you is how to do these symbols. You ready? Here's how this works. This means intersect. This means union. Intersect. And this means union. What the heck does that mean? Intersect is, if I took Highway 101, which runs north-south, and Highway 7, which runs east-west, would you agree in the middle that's where the intersection is? It's not everywhere, it's just the places where they overlap. That's the intersection. So do you get that the intersection of these circles would be like there? Does that make sense to you? It's where they overlap. That's what intersect means. How about union? Union means a big group. I remember reading this somewhere, the Union of the United States of America. It's a union of a whole bunch of states that are all going to go together. Because remember, at the beginning, we weren't. It was like separate things. The states weren't part of one nation. They were just separate completely. And they decided to join up and make the Union of the United States of America. So anyway, union is a big group. So this is a union. It's everybody, except the people from Russia that aren't in the Union. Or, you know what I mean? There's always somebody not in the Union. Union means all of the groups, but not necessarily everybody. So unions are big answers, intersect are small answers. Besides, any union person would tell you that they always want a big union. Lots of people in the union. It makes it more strong than if it's small. So unions go for big, intersect, you're looking for small. All right. There you go. I think that'll give you, oh, and I guess the only other thing, it says only G. That means G, but not the other things. So when you're making your Venn diagram, like you do on this problem, be careful. People really mess this up because they'll say like, okay, I got tennis, and can you read higher up? So I can't scroll, but it's tennis, and what's the other thing? Golf. People will hear that like 20 people play tennis, and they slap the 20 in right there, and they're doomed. Remember, these together are the people that play tennis. If you have a total of 20 people playing tennis, put a 20 there. Don't slap it here. These two together add up to all the tennis players. Okay, that's the last of my advice, and that's all I got for you for today.